Hi class, today I want to talk to you a little bit more about ggplot, a few things I didn't get to in those first couple of videos. So I'm going to share some code and run that code with you today. I'm not going to do all the coding live like I did before, mainly because these are sort of extra things and not core to what you'll do in ggplot. So as usual, I start by setting my options, loading libraries, and loading some data. So once again, I'll be using the penguins data from the Palmer Penguins library, and I'll be using my garden data. So there's so many things ggplot can do. It's impossible for me to teach them all to you, but I'm just going to show you a few more. So one is side-by-side and filled bar plots. Let's start with a simple example using the penguins data. We will create a bar graph that shows the distribution of islands that the different species live on. In terms of ggplot aesthetics, we are putting species on the x-axis and coloring the bars by island. And actually, I should say filling the bars by island. So if I run this code, let me first talk through it. I take the penguins data and then ggplot it, putting the species on the x-axis, island, and filling by island, and creating a bar plot. And there's our plot. So in this plot, we can clearly see the count of each species, right? We can see that there's just over 150 Adelie penguins. There's, maybe around 65 chinstrap penguins and so on. It's a little difficult to know the counts on each island within species. So for example, if I wanted to know of the Adelie penguins, how many of them live on Dream Island, that's, I have to do a little bit of math in my head to figure that out. So we'll come back to that issue in a bit. We could also show the distribution of species on each island by flipping the X and fill aesthetics. So here I take the penguins data and then ggplot it, put island on the x-axis and fill by species. I did the opposite thing before. Okay, so here it's really easy to see the counts on each island. It's harder to see the counts of each species within each island. So again, to find how many Adelie penguins are on Dream Island, I now have to do a little bit of math in my head. So one of the ways we can fix that is by doing side-by-side bar plots. So here, I add this argument to g_on_bar that is position equals dodge, and this means the bars dodge each other or that they're next to each other. Okay. So in this graph, what we can see better now is how many of each species are on each island. It's harder now to see how many total penguins are in each island, except for on the Torgerson Island, where it's only one species. But with these other two, Bisco and Dream Island, we have to do a little bit of math to see that total, or to compute that total. If we're less concerned with counts, but more with the proportions, we can fill the bars so their lengths represent proportions. So here I've changed this position argument to position equals fill. And we'll see that although it labels this count, which I typically would change, so I've changed the Y label here. These boxes or these bars or rectangles actually represent proportions now. So we can see that on Bisco Island, about 75 or just under 75% of the penguins are Gen 2 species. These are all good graphs, but they answer different questions. So one of my points is that when you're designing your graphs, you should think about the question that you're trying to answer, then make sure your graph actually helps answer that question. I know it's easy to get caught up in the details of ggplot, So, you know, just reiterate to yourself the question you're asking and make sure that that graph answers the question. Let's move on to some other graphs. And I'm going to use my garden data on these graphs. And first, I'm going to create a couple of data sets. And actually, I don't think I end up using this daily one. So this weekly data set I created has the weekly harvest in pounds for each vegetable. And let's say we're interested in seeing how the type of vegetable harvested changes week to week. One way we could do this is using a similar bar plot to what we just talked about with the penguins data. We'll create a bar plot where we put week on the x-axis, weekly weight in pounds on the y-axis, and color by vegetable. Since we're using the bars to represent weight, we put in the y-axis, whereas before it did it for us since it was computing counts. And we use geom_col instead of geom_bar. I've also colored differently and modified this theme so the axis is at the bottom. No, I'm sorry, so that the legend is at the bottom. And let me run this code so you can see it. And just regarding the code, you might be asking yourself, you know, how would I know how to do something like theme legend position equals bottom? Truthfully, this is one that I always forget. So if you go to help, cheat sheets, I highly recommend clicking on that data visualization with ggplot2 cheat sheet. I have this open almost all the time. So I've already downloaded it. When you click on that, it'll download it, and then you can open it up and you get this thing. So that moving the legend, if I go look to this legend thing, I see that right there, theme legend position equals bottom. I go to this cheat sheet all the time for that exact thing. Okay, now back to the plot. So this is okay, but there's a couple things I don't like. So one is that there's too many categories to be nicely represented with colors that are distinguishable from one another. So for example, when I'm looking up here, I can't really easily distinguish, let's say, radishes from raspberries, especially since there's so few of those. Truthfully, for me, anything from asparagus to beets looks fairly similar to me. And you know, in this cilantro, corn, cucumber range, those look pretty similar, and so on. Even if we could distinguish the colors, it does get difficult to compare the different colors because they can start in different places from week to week. So for example, at the beginning, I don't have any tomatoes and zucchini. They take a while to come in. So, you know, if I want to compare the harvest of lettuce from here to here, it's really hard to do that. So let's try a different type of plot using geom_tile. Here, each vegetable and week will be represented by a small rectangle on a grid. We will fill in the rectangles according to weight. Okay, so here I can easily find the different vegetables, right? And I can sort of easily within vegetables see how that has, you know, the harvest has grown or shrunk or varied from week to week. But this still doesn't quite get what I want. So first, the vegetables are in alphabetical order, which in this case is not really helpful other than I can find the vegetable fairly easily, but it's not very meaningful. Second, the color scale doesn't seem to work very well since there aren't many vegetables that have weekly harvests greater than 20 pounds. Truthfully, there aren't many that have harvests more than 5 pounds. And third, I would like to get rid of these grid lines. So let me run this code and we'll come back and talk about some of the detail. So I'm using geom_tile again. So, and I think I've neglected to mention this earlier. Here I've put week on the x-axis. I am putting a variation of vegetable on the y-axis, and I'm filling by weight. So let's see what this looks like. So this seems to look a little bit better. Although it's still hard to distinguish some of these lower values, and it sort of is going to be hard because there's so many of the same small values or similar small values. So a couple other things I want to point out though are this scale fill gradient. So here I've chosen the low and high colors and the midpoint color. I've also told it what I want the midpoint to be. So I've said 10 is the midpoint. We could certainly play around with this to see if we can get a better picture. So I don't know, perhaps we do try 20 and sort of see if that gives us more variation. So maybe we like something like this where now we're seeing more of those sort of darker blues and lighter blues. It gives us a little more variation. The other thing I'm just realizing right now is we have a lot of blank spaces, but we can't tell the difference between a blank space and our midpoint, which is also white. So we might want to think about changing our midpoint to something that's not white, just in case some of this whiteness, so like here we see some whitish color, just so that white, you know, isn't our midpoint. Perhaps what we want to do is make white the low point, and we could make the steel blue 4 the midpoint. This also might not be the greatest idea. Okay, so now we get some purples in there. Maybe this isn't the best idea either, but that's something we should sort of play around and try to perfect. Okay, so yet another way that we could look at the data is via line graphs. So looking at this plot here, this is one, we've seen one similar to this before. This still looks really busy. There's a lot of labels. So one thing I want to show you is this gghighlight highlight function from the gghighlight highlight library. So using this gghighlight highlight function, which you can use within the ggplot plots, we are going to highlight the lines for vegetables where the biggest weekly harvest was more than 5 pounds. So any vegetable that had a weekly harvest bigger than 5 pounds will be highlighted on its own. So let's run this. So now we can see we no longer have our labels for the various colors. We just have for the, let's see, 6 vegetables that had weekly harvest greater than 5 pounds. Those have been colored and called out, and their labels are actually right on the plot. And we could customize these labels a little bit more. I see that some of them we might want to move around a little bit because they sort of overlap one another. But this looks a lot better and a lot less busy than this graph. So just another tip as you're creating plots. And that is all I have to tell you about for now. Bye-bye.